Hello, discrete math fans. We need to make a distinction between these two symbols. This is element of and subset of. They're both going to involve sets, but they're used in very different ways. So we need to be very careful about how we use them. As an exercise, let's go through these 5 statements and decide which of them are true. What I would suggest that you do now is pause the video and work out for yourself which ones of these statements are true. Go ahead, pause the video, and write down on paper what you think are true. So the only true statements here are A and C. B, D, and E are false. All right, for part B, the set containing 1 is an element of the set containing 1, 2, 3 is false. The only elements that are in the set 1, 2, 3 are the numbers 1, 2, 3. This object here, the set containing 1, is not one of those elements. So that statement is false. However, if I change the set on the right side so that the objects in the set are no longer the numbers 1, 2, 3, but the sets containing 1, the set containing 2, and the set containing 3, now the set containing 1 is one of those things, so this is a true statement. D is false, and we don't have to do very much work at all. 1 is not a set, so it can't be a subset of anything. I would go so far as to say that not only is this statement false, it's nonsense. Finally, part E is false. What are the objects that are in the set on the left side? There's one thing, the number 1. What are the objects on the set on the right? There are 3 things in there, and they're all sets. The set containing 1, the set containing 2, and the set containing 3. There are no numbers in this set. This set only contains sets. Remember, we talked about how sets can have lots of different types of things in there. The objects in a set can be numbers, they can be vectors, they can be matrices, they can be any sort of mathematical objects. They do not necessarily have to be numbers. And in this case, the objects in the set on the right-hand side are themselves sets. The only object on the left-hand side is the number 1. So everything that's in the set on the left is not in the set on the right, and so this statement is false. Okay, that's all for now.